Welcome back. Let's start our discussion with exception handling. So, what is an exception? An exception is an event which occurs during the execution of a program that disrupts the normal flow of the program's instruction. An exception is a Python object that represents an error. So, when a Python script raises an exception, it must either handle the exception immediately, otherwise it terminates and quits the program. Handling an exception. If you have some suspicious code that you think may raise an exception, you can defend your program by placing the suspicious code in a try block. After the try block, we need to include an except statement followed by a block of code which handles the problem as elegantly as possible. So here's your syntax. Try whatever code which we think might cause an exception in our program, then accept exception 1. So if this exception occurs, then this part of the program should be executed. If this exception occurs, then this part of the program should be executed, and if nothing occurs, then if there is no exception, then this part of the program should be executed. So so a single try statement can have multiple except statements, like we saw in the syntax. This is useful when the try block contains statements that may throw different types of exceptions. You can also provide a generic expert clause which handles an exception. After the except clause, you can include an else clause, like we have done in the syntax. The code in the else block executes if the code in the try block does not raise an exception. The else block is a good place for code that does not need the try block's protection, which means that we usually include the codes which we are sure might not throw an exception in the else block. So here's an example. This example tries to open a file where you do not have write permissions, so it should raise an exception. So for example, we write a file, say test file, which do not have write permission, which has only read permission. So we know that this command over here should raise an exception because the file is opened only in read only mode. So we are placing the above code in a try block, and then we are writing except input output error, print this, else print this. So this part of the code is going to raise an input output error. So when we encounter an input output error, the program automatically jumps to this block and it prints whatever is written inside the except block. So here we see the result is the string which has been asked to be printed in the except block. Coming to classes and objects. Python has been an object-oriented language since it existed. Because of this, creating and using classes and objects are downright easy. Creating classes. The class statement creates a new class definition. The name of the class immediately follows the keyword class followed by a colon as follows. Here's an example. So we are defining over here a class employee, and we are defining various characteristics of the following class. So class employee colon mcount equals to 0. Then we are writing a function. We are defining a function, init function, and we are giving the following parameters: self, name and salary. Then we are writing the characteristics of the function: self.name, we are giving it a name, self.salary, whatever salary, and employee.mcount equals to employee.mcount plus 1. Then we are defining another function called display count, and the parameter is self, and then we are printing the total employee whatever is the count, and we are defining another function called display employee with self parameter, and we are printing the name and the salary. now we'll learn how to create instance objects. To create instance of a class, you call the class using class name and pass in whatever argument its init method accepts. So here we are defining two objects, M1 and M2, and we are calling the class employee and giving the parameters Zara and 2000, and M2 as employee money 5000. So here we see that the init method includes parameters like name and salary other than self. So the name here is Zara and money, and the salary is 2000 and 5000 respectively. We need to note here that the sequence in which the parameters are described over here is similar to the sequence of the parameters described over here. We are not supposed to jumble the sequence or manipulate it. Accessing attributes. So whenever after we have defined an object of a particular class, we can use the dot operator with the object and access the various attributes of that particular object. So now if we are writing emp1 dot display employee, so the function display employee prints name and the salary of the particular person. So emp1 is Zara and the salary is 2000. So here when we are writing emp1 dot display employee, emp2 dot display employee, it should print name Zara, salary 2000, name money, salary 5000, and the total employee 2, which is written in the last line. Here I have just put all of the code down together for easier reference. You can take a look at it. You can add, remove or modify attributes of classes and objects at any time. So here we are adding age attribute to the various objects and we are deleting the age attribute. So instead of using the normal statement to access attributes, you can use the following functions: get attribute, get attr, object name default to access the attribute of object, has attribute object name to check if an attribute exists or not, set attribute object name value to set an attribute. If the attribute does not exist, then it would be created. The del attribute to delete a particular attribute of an object. So has attribute emp1 age. So as we have already included the age attribute to emp1, so it will return true when age exists, which it does. Has attribute emp1 age, get attribute emp1 age will return the value of age attribute. Set attribute emp1 age 8 will set the value of age attribute to 8. Del attribute this would delete the attribute age. Coming to multi-threading, running several threads is similar to running several programs concurrently, but with the following benefits. Multiple threads within a process share the same data space with the main thread and can therefore share information or communicate with each other more easily than if they were separate processes. Threads sometimes called lightweight processes, and they do not require much memory overhead. They care cheaper than processes. A thread has a beginning, an execution sequence and a conclusion. It has an instruction pointer that keeps track of where within its context it is currently running. It can be preempted, that is interrupted. It can temporarily be put on hold, also known as sleeping while other threads are running, and this is called yielding. So when we start a new thread, we can use the following function: thread.start new thread, the function arguments. Here is an example. So we are importing the library thread and we are importing the library time. Then we are defining a function print time, and the parameters are thread name and delay. Count, we are setting the value of count to 0, and then we are creating a loop that till the time count is less than 5, we are we are setting the time to sleep till the amount given in the delay, and then we are increasing the count by 1, and then we are printing the thread name, the time dot c time, and the close time and of that particular time. Then we are creating two threads as follows. We are starting a new thread. We are calling objects. The first thread name is thread 1 and the delay is 2. The second thread name is thread 2 and the delay is 4. So, and then we are creating an except block which prints error unable to start thread and while 1 pass. So this will always continue the loop, and the above code is when the above code is executed, it will produce the following result: thread 1 and that particular day, date and time and year, and likewise. Our last topic will be Python GUI programming. So there are various graphical user interfaces which gives us the option of developing in Python. Most importantly and widely used is Tynker. You can have a look on it in the net. You'll find various tutorials to guide you on how to use Python using Tynker, and it is the Python interface to the TK GUI toolkit shipped with Python. Then there are something called JPython, WXPython, which are also interfaces which are used along with Python, and there are various other interfaces available on net as well. Thank you.